let f of x equal 3 plus root x plus 4 all over x minus 6. Let's find the domain of this function f. Then find and simplify f of negative 3 and f of 41. So you'll note that the stuff in the absolute value is x plus 4, and we need that to be greater than or equal to 0. We also need to avoid the situation when the denominator equals 0. So we should avoid x minus 6 equals 0. So take the inequality, subtract 4 on both sides. We need x to be greater than or equal to negative 4, but we also need to take that equation x minus 6 equals 0, add 6 to both sides. We have to avoid the situation when x equals 6. So all numbers from negative 4 on upward to bigger numbers work with one exception. 6 does not work as an input because we need to avoid that number. Plugging in 6 for x would cause the denominator to be 0, and we don't want that. Okay, so the domain is bracket negative 4, comma 6, parenthesis, union, parenthesis, 6, comma, infinity, parenthesis. Okay, well, then negative 3 is in the domain. Yeah, negative 3 is between negative 4 and 6, so that's fine. It's in the domain. So negative 3 is actually valid as an input. And I get that x is negative, but we're not going to end up square rooting negative 3. We're going to plug in negative 3 for x. And then in the radical, it'll be root negative 3 plus 4, which will simplify to root 1. So we'll only be rooting the number 1. So that's fine, right? Same thing, 41 is in the domain, so 41 is valid as an input. So to find f of negative 3, to plug in x equals negative 3, to use the input to be negative 3, we'll have 3 plus root, there's an x that got replaced with negative 3, so negative 3 plus 4, all over negative 3 minus 6. We'll simplify this to be 3 plus root 1, all over a negative 9. In other words, 3 plus 4 over negative 9. So yeah, sorry, 3 plus root 1 is 3 plus 1, which is 4. So 4 over negative 9. Same deal to find f of 41. I think it's super important to say of. Don't think f times 41. There's no multiplication going on here, right? So this is 3 plus root 41 plus 4 all over 41 minus 6. We'll simplify that to 3 plus root 45 over 35. And we'll skip some of the work here, but root 45 is root 9 times 5. And when you have multiplication in the radical, you can split that up. That's one of our formulas. So that'll be root 9 times root 5, and the root 9 just was written as a 3 instead. So 3 plus 3 root 5 all over 35. Now, to review what we saw last time, if c is positive, what do you do to the graph of y equals f of x to get the graph of y equals f of x plus c, y equals f of x then minus c, then y equals c times f of x, and y equals negative f of x. So you either shift up, or you shift down, or you stretch vertically by a factor of c, or you flip vertically. Now the use of charts today, just like last time, is going to be, it's used to discover a more general pattern. It's meant to, we're using the charts today to understand behavior of these functions and what happens when you shift things and stretch things and so on. Do not use these charts as the only way to graph a function. That is not going to be sustainable. It's not going to work. Please hear this message, that you have to not rely on the charts alone. Okay? That is, once the behavior and pattern is learned, you no longer need to rely on these charts. So you should really go through the computations you see here on your own instead of just watching. The computations themselves, I promise, aren't so bad, but going through them will make it more convincing to you what's going on here. So first, before we dig into things, let's just note that root x plus 4, you cannot split up the radical and turn this into root x plus root 4. Okay, so if you turn this into root x, then plus 2, same deal. That's the same problem.